A very happy morning, children. This is Chemical Science, Unit 15, Carbon and its Compounds, Part 1. So the lesson name is Carbon and its Compounds. So after completing this lesson, you will be able to explain the special features of carbon, know about the isomeric and allotrophic forms of carbon compounds, and you will recognize the various inorganic carbon compounds and their uses, and you will identify the codes of various plastics, and you will know the legal measures to prevent plastic pollution. So before going to the lesson, we will see the introduction. So see, introduction, you have 4 important points in the introduction which you must know before you go deeply into the lesson. So what are they? The first point is non-metallic. So carbon is one of the most important non-metallic element. Antoine Lavoisier named carbon from the Latin word carbo, which means coal. So Lavoisier is the name of the scientist who named carbon, deriving it from the Latin word carbo, which means coal. So carbon is nothing but coal. And it is clear that all the life forms contains carbon because coal is a fossil fuel, right? It is developed from the prolonged decomposition of buried plants and animals. So it is clear that all the life forms contains carbon. So the Earth's crust contains only 0.032% of carbon. So in the form of minerals like carbonates, coal and petroleum, and the atmosphere has only 0.03% of carbon dioxide. So even though available in small amount in nature, carbon compounds have an immense importance in everyday life. Thus, carbon chemistry is also called as living chemistry. So these are the points which you should know about the carbon. Okay, so carbon is nothing but it is a non-metallic element. It is derived from the Latin word carbo, which means coal, by the scientist Antoine Lavoisier. And in the earth crust, 0.03% of carbon is available, and the carbon chemistry is also called as living chemistry. And second, you are going to see the discovery of carbon. Who are all the scientists who discovered the compounds of carbon? So first one is Antoine Lavoisier, who discovered diamond and charcoal. So he kept diamond inside a glass jar and he passed the sun rays with the magnifying glass and he saw the diamond burn and disappeared. So which burns and disappear? Only the coal burns itself and disappear and become into a black color charcoal. Okay, so diamond is nothing but it is derived from coal. Okay, so when it is burned, the diamond had combined with oxygen to form carbon dioxide. So he concluded the diamond and charcoal were made of the same elements, carbon. So then Carl Scheele, so he found out graphite is also a form of carbon. Then Smithson Tennant, diamond is a pure carbon. So he found that diamond is a pure carbon. Okay. Then Benjamin Brodie and Francis Bundy, they also again classified and clearly explained that graphite is a pure form of carbon. Then Robert Curl, Harry Croto and Richard Smalley, they also found the other compounds of carbons like fullerenes and graphene. And the last one is Kostya Novoselov and Andrew James, and they framed new form of allotropes. So these were the scientists who discovered the other form of carbons. Okay, then the third topic what you must know is classifications of carbon compounds. It is nothing very simple, classified into 2, organic compounds and inorganic compounds. Organic and inorganic. Organic is nothing but it is derived from living organisms. Okay, so it is derived from living organisms. These are the compounds of carbon obtained from living organisms such as plants and animals. Example, ethanol, cellulose and starch. Then the second is inorganic compound. This is also nothing but the compounds containing carbon but obtained from non-living matter. Example, calcium carbonate or carbon monoxide CO and carbon dioxide CO2. Okay, so these are the 2 classifications of carbon, organic compounds and other one is inorganic compounds. Organic compounds is nothing but carbon, organic carbon compounds contain carbon connected with other elements, not only carbon. This organic compounds will contain carbon connected with other elements like hydrogen, oxygen, nitrogen, sulfur, etc. And after they combine with these elements, they are called as hydrocarbons, alcohols, aldehydes and ketones, carboxylic acids, amino acids, etc. As such, inorganic compounds are like oxides, carbides, sulfides, cyanides, carbonates and bicarbonates. These are the major classes of inorganic carbon compounds. Okay, so this is about organic compounds and inorganic compounds. So in brief, we will see the special features of the carbon compounds that is given in the tabular column, page number 174. Special features of carbon compounds given in page number 174, and the special features are like catenation, tetravalency, multiple bonds, isomerism and allotropy. These are the special features of the carbon compounds. And the fifth one what we are going to discuss is the properties of carbon, that is physical properties and its chemical properties, by seeing the book. Okay, so now we will see in brief the special features of carbons. So what are the special features? Catenation, tetravalency, multiple bonds, isomerism and allotropy. This is the tabular column given in the book, page number 174, for the special features of carbon compounds. Okay, so you have 4 columns here: compounds, formation, properties and uses. So the compounds given here are carbon monoxide, carbon dioxide, calcium carbide, carbon disulfide, calcium carbonate, sodium bicarbonate. See the formula: sodium bicarbonate NaHCO3. And the uses of sodium bicarbonate are preparation of sodium carbonate, baking powder, antacid. And calcium carbonate is used as an antacid. Carbon disulfide is used as a solvent for sulfur to manufacture rayon, fungicide, insecticide. Calcium carbide is used to manufacture graphite and hydrogen to prepare acetylene gas for welding. Then carbon dioxide, it is used as a fire extinguisher, preservative for fruits, making bread to manufacture urea, carbonated water, nitrogenous fertilizers, dry ice in refrigerator. Then carbon monoxide is a main component of water gas, CO plus H2, and it is used as a reducing agent. And you can see the formation and properties of all these compounds. Go through this tabular column. It may ask in 2 mark, or in 4 mark, or in 7 mark. Okay, so be thorough with this tabular column. So next we will see the special features of the properties, and first one comes under that special feature is catenation. Now define catenation. Is 2 mark question. Define catenation. So catenation is nothing but is binding of an element to itself or with other elements through covalent bonds. So what is catenation? Catenation is binding of an element to itself or with other elements through covalent bonds. Binding means grouping together or connecting or joining or handing together, like that. Okay, so binding of an element to itself, to same carbon compound or with other elements, or it may combine with hydrogen or nitrogen or sulfur or oxygen, whatever element. Okay, through covalent bonds. So carbon is the most common element which undergoes catenation and forms long chain compounds. And see the chain formation here. So these are the branched chain. The first one is the branched chain. You can see the branches of the carbon atoms here. C is connected to C, C is connected to C. So the small line which connects the carbon and carbon atom are called as bond. It is called as bond. Okay. And the second reaction, this is linear chain, straight chain without any branches. Then the third one is ring chain. Ring chain, you can see triangle shape, triangle shape, then pentagon shape and hexagon shape. So here all carbon atoms are connected by a single bond. The small hyphen which connects all the carbon atoms are called as bond. Okay. So this is the catenation in carbon. So this property of carbon itself is the reason for the presence of large number of organic carbon compounds. So organic chemistry essentially deals with catenated carbon compounds. So for example, starch and cellulose contains chains hundreds of carbon atoms. So this is an important one. Okay. Even plastics we use in our daily life are macromolecules of catenated carbon atoms. So give me examples for carbon compounds. Catenated carbon compounds. The answer is this. Starch and cellulose contains chains of hundreds of carbon atoms. Even plastics we use in our daily life are macromolecules of catenated carbon compounds. Next we are going to see tetravalency. So what is tetravalency? Tri means 3. Tetra means 4. Tetra means 4. Okay, so carbon's outermost shell has 4 electrons. Okay, so its atomic number is 6 and the electronic configuration is 2, 4. Here it is given 2, 4 and atomic number is 6. So it has 4 electrons in its outermost orbit. So according to octet rule, octo means 8. That is why octopus is called as 8 fingers. It has 8 projections like. So that is why it is called as octopus. So octet means 8. So carbon requires 4 electrons to attain noble gas electronic configuration. So noble gas, neon, argon, xenon, krypton, radon, these are called as noble gas, which are called as lazy gases because they doesn't take part in chemical reaction. Okay, so this carbon also want to be a lazy element without involving in chemical reaction. So that's why it is in need of other 4 more electrons. It already has 4 electrons, but it is in need of other 4 more electrons. So it combines with the other atom to get 8 electrons so that it will become a lazy element. Okay, so such type of combination when it combines with other atoms to attain its octet rule is called as tetravalency. So at that time it has a valency of 8 electrons. So it is called as tetravalency. Okay, so complete its octet rule. So this is called as tetravalency. Thus carbon can form 4 covalent bond with other elements. For example, in methane, you can see here. In methane, see, carbon has only 4 outermost electrons. It combines with hydrogen. So it combines with the hydrogen and it becomes 8 electrons in the outermost shell. So C combines with hydrogen, 4 atoms of hydrogen. Okay, so 4 plus 4, carbon already has 4 electrons and this hydrogen has 4 electrons. So 4 plus 4 will become 8 electrons. So the formula for methane is 1C and you have how many? 4 hydrogen, 4 atoms. So this is the formula for methane, CH4, CH4. Okay, so now this will become an tetravalent compound. Okay, so this is called as tetravalency. Next, multiple bonds. Multiple bond means when carbon combines with carbon, we connect it by single hyphen. Okay, so if there is a single line, it is single bond. If there is double line, it is double bond. If there is triple line, it is called as triple bond. So with this tetravalency, carbon is able to combine with other elements or with itself through single bond, double bond or triple bond. So as we know that nature of bonding in a compound is the primary factor which determines the physical and chemical characteristics of a compound. So the ability of carbon to form multiple bonds is the main reason for the existence of various classes of carbon compounds. So in the below table, such classes of compounds are called hydrocarbons and it is given here in the table. So see, single bond, the single bond methane and belongs to the compound alkane. Then double bond is ethene. So you can see the bond here. When carbon is connected with a double line, it is called as double bond. Okay. So it is called as ethene and the compound is alkene compound, comes under the class alkene. Then the next one is triple bond. You can see the triple bond here, 3 lines and it is called as ethyne and comes under the class alkyne group. So when one or more hydrogen in hydrocarbons is replaced by other elements like oxygen, nitrogen, sulfur, halogens, a variety of compounds having different functional groups are produced. So many groups are produced when carbon combines with many other atoms, not only with the hydrogen. Carbon combines with oxygen, nitrogen and sulfur as well as with the halogens also. So you have more number of functional groups when combined with the carbon. So that and all you will study in your later classes, maybe in +1, +2 or even in colleges. When you take chemistry as your major, you can study more about all these carbon compounds, functional groups of carbon compounds. The next, isomerism. So what is isomerism? Is another very important one. Very important topic, isomerism. Okay, so isomerism is another special feature of carbon compounds, especially found in catenated organic compounds. So that is in the organic compound. See the formula C2H6 and O. So isomerism is nothing but formula will be same for the two elements. Okay, two compounds. Formula will be same, but the structure differs. Formula will be same, but the structure differs. This is the called as isomerism. Okay, so because the molecular formula of an organic compound represents only the number of different atoms present in that compound. So it does not tell about the way in which atoms are arranged and hence its structure. Without knowing the structure, we can't name it. So without knowing the structure, if we know the formula and without knowing the structure, we cannot give name of that compound. So a given molecular formula may lead to more than one arrangement of atoms. Such compounds are having different physical and chemical properties. This phenomenon in which same molecular formula exhibit different structural arrangement is called isomerism. 2 mark question, define isomerism. Same molecular formula. It will have same molecular formula but the structure differs, but with different structural arrangement is called isomerism. Or you can write this here. Compounds that have the same molecular formula but different structural formula are called isomers. Compounds that have same molecular formula but different structural formula are called isomers. And in Greek, isos means equal, meros means parts. The given formula C2H6O is having two kind of arrangement of atoms as shown here. See here. C, you have 2 carbon atom here, here also 2 carbon atom. H3 plus 2, 5, 5 plus 1, 6. 3 plus 3, 6. So here also hydrogen 6, here also hydrogen 6 atoms. And oxygen only 1, here also oxygen only 1. So the formula is same for both the compounds. But see the structure differs, isn't it? So the structure of the compound differs. So it has the same formula C2H6 and O. The structure different. So such type of compounds have different molecular formula but same molecular formula but different kind of arrangements. So in compound A, it is called as alcohol. It is alcohol. Name is alcohol. Whereas compound B is called as ether. Compound A is called as, that type of arrangement is called as alcohol. The second arrangement is called as ether. Okay. So in brief, you will study about this alcohol, this arrangement of carbon and hydrogen compound in your higher classes. So next is allotropy. This is also an important 2 mark question, children. So what is allotropy? Allotropy is a property by which an element can exist more than one form that are physically different and chemically similar. It exists more than one form, physically different and chemically similar. So different forms of elements are called its allotropes. So different forms of same compound, same element is called as allotropes. So allotropes means physically different, chemically similar. The main reason for the existence of allotropes of an element is its method of formation or preparation. How does allotropes exhibit? Because of the preparation. When the preparation method changes or the formation of the compound gets changed due to any of the physical or chemical properties, then new form of compound is formed that is called as allotropes. So carbon exists in different allotropic forms and based on their physical nature, they are classified as diamond, graphite and fullerene. They are classified as diamond, graphite and fullerene. Okay, so now we will see a brief discussion about the structure of the diamond. So in diamond, each carbon atom shares its 4 valence electrons with 4 other carbon atoms forming 4 covalent bonds. So each carbon atom share its bond with other 4 carbon atoms. Okay, so that is the first point. Then second, it is repeated tetrahedral. So tetra means 4. So it is repeatedly tetrahedral fashion which leads to 3-dimensional structure accounting for its hardness and rigidity. Okay. So next is graphite. In graphite, each carbon atom is bonded to 3 other carbon atoms through covalent bonds in the same plane. And this arrangement forms hexagonal layers, which are, hexagon means 6. Okay, hexagon means 6 layers which are held together one over other by weak van der Waals forces. So each carbon atom is held over the other carbon atoms but due to weak van der Waals force. That force between each carbon atom is called as van der Waals force, but it is weak. It is not as strong as it is in diamond. Here it is a weak van der Waals force. So it is very, very, very softer than diamond. Graphite is very softer than diamond. Okay, since the layers are held by weak forces, graphite is softer than diamond. Then about fullerene, a third crystalline allotrope of carbon is fullerene. The best known fullerene is Buckminster fullerene. Best known fullerene is Buckminster fullerene, which contains 60 carbon atoms. How many carbon atoms? 60 carbon atoms joined together in a series of 5 and 6 membered to form spherical molecule resembling a soccer ball. So how does it look like? It looks like a soccer ball. And its formula is C60. Its formula is C60. This allotrope was named as Buckminster fullerene after the American architect. After the American architect. Okay. So now see here you have the difference between diamond and graphite. 2-mark question. Okay. So please go through this. So next we will continue with the same fullerene. So it is named after scientist Buckminster Fuller because its structure reminded the framework of dome-shaped halls designed by Fuller for large international exhibitions. It is called by the pet name Buckyball. A large family of fullerene exists starting at C20 and reaching up to C540. Okay. So then the second one is amorphous forms of carbon. In amorphous form of carbon, atoms are arranged in a random manner. However, it is like a zigzag motion in linear chain or in a branched chain. It is arranged in a random motion. These forms of carbon are obtained when wood is heated in the absence of air. When does it occurs? When wood is heated in the absence of air. Example, charcoal. So now we will see some structures of this diamond, graphite and fullerene. So this is the carbon linked with the hydrogen. Okay, the center black one is the carbon and the two red balls are the hydrogen. Okay, so this comes under linear chain carbon compound. This is a linear chain carbon compound. So this is how this is the tetravalency compound. Carbon combines with the 4 hydrogens. Okay, so this structure looks like this. Tetravalency carbon compounds look like this. And this is the structure of diamond. Okay, this is the 3-dimensional structure accounting for the hardness and rigidity. Okay, so this is a normal structure. Actually, this is a normal structure of the diamond. Okay, 3D view. And this structure is the structure given in the book. A normal structure of the diamond. Normal structure of the diamond. Okay, tetrahedral carbon atoms which is connected with the other 2 hydrogen atoms. Again this will connect to carbon atoms and hydrogen atoms so that the structure will keep on exhibiting. Hence this is the Pakka 3D structure accounting for diamond shape. Okay, so this is how full diamond, very hard. Okay, this is a very hard structure of diamond. So you can see the tetrahedral shape of the compounds when it is get turned over. So it is very hard. The diamond is very hard to break. Is that clear? So this is the 3D dimension of diamond. And this is the structure of graphite. So you can see the tetrahedral carbon connected to each carbon atoms and it is connected due to the weak van der Waals force. It is connected to the weak van der Waals force. Hence it is very softer than diamond. And this is the structure of fullerene. So this looks like a dome shaped hall or like a ball shaped. Okay, so this is called as a ball shaped Buckminster fullerene structure. Looks like a ball. Okay, football, Bucky ball. And C540 or C20 and 60 carbon atoms are arranged here and it is connected each other and forms the circular shape. Looks like a ball. So now we will see the physical properties of carbon and its compounds. The first point, carbon is a non-metal found in various allotropic forms. From soft powder to hard solid. All allotropic forms of carbon are solids whereas its compounds exist in solid, liquid and gaseous state. Okay. Amorphous forms of carbon and graphite are almost black in color, opaque. Diamond is transparent and shiny. Its amorphous forms have low melting and boiling point compared to crystalline forms. Carbon is insoluble in water and other common solvents, but some of its compounds are soluble in water and other solvents. Example are, this may ask in 2 mark. Okay, so read it properly. Examples are ethanol, carbon dioxide are soluble in water. So next we will see chemical properties. Physical and chemical properties all together may ask in 7 mark question, children. So be thorough with these 2 answers. So elemental carbon undergoes no reaction at room temperature and limited of reactions at elevated temperatures, but its compounds undergo large number of reactions even at room temperature. So we will see the oxidation of reaction with the oxygen. Oxidation of carbon atom that reacts when oxygen is combined together. The carbon combines with oxygen to form its oxides like carbon monoxide and carbon dioxide. When carbon combines with the oxygen, it forms carbon monoxide and carbon dioxide. Okay, it undergoes oxidation to form oxides and steam with evolution of heat and flame. So when they combine together, it evolves heat and flame. This is otherwise called as combustion. This is called as combustion. That is why a material burns. Okay, when carbon combines with oxygen, it emits out heat and flame. So this process is called as combustion, and it forms carbon monoxide and carbon dioxide. So see the reaction. Carbon plus oxygen gives carbon monoxide. Carbon plus oxygen gives carbon dioxide plus heat. And this methane plus oxygen gives carbon dioxide plus water plus heat. Okay. So next is reaction with steam. A carbon reacts with steam to form carbon monoxide and hydrogen. This mixture is called water gas. Important 2-mark question. Okay. How does water gas formed? The carbon reacts with steam to form carbon monoxide CO and hydrogen H2. So this mixture, this carbon monoxide and H2 mixture is called as water gas. So carbon reacts with the water to give carbon monoxide and hydrogen. This is called as water gas. Then reaction with sulfur. With the sulfur, carbon forms its disulfide. Okay, at high temperature. So carbon plus sulfur gives carbon disulfide CS2. Carbon, di means 2, disulfide. Okay. Then reaction with metals. At elevated temperature, carbon reacts with some metals like iron, tungsten, titanium, etc. to form their carbides. So tungsten. So where does tungsten present? Inside the bulb. Okay. Tungsten is present inside the bulb. So carbon, tungsten plus carbon gives tungsten carbide. Tungsten carbide. So up to this session we have completed. So we have covered about the carbon and its compounds, its physical structure, its classifications, its in discoveries, special features, okay, and properties, physical properties and chemical properties. So I want you all to go through all the topics whatever we have covered today, and in the next session we will discuss the book back questions. Okay, and also we will see in the next session about plastics, because plastic is one of the compound of carbon which we use in our daily life a lot. So we are going to see about plastics, its drawbacks, and how to identify type of plastics, benefits and demerits of plastics in the next session. So children, please go through the topics whatever you have learned here in this session. Okay. Thank you children. Have a good day.